Welcome to the first revision lesson on plate tectonics. In these revision lessons, we're going to revise the layers of the Earth, how and where volcanoes form, the different types of volcanoes, how and where earthquakes happen, and different types of earthquakes. Firstly, we need to recap the structure of the Earth. This should sound familiar because we've already studied this together earlier in the year. The Earth is made up of three main layers. The top and the outermost layer is called the crust. The crust is solid and is made of rocks, like granite. It's between 50 and 100 kilometers thick, and compared to the thickness of the other layers of the Earth, the crust is a bit like the skin on an apple. You wouldn't think it where we are, standing on the Earth's surface, where the temperature is cool and everything seems really quite stable. But at the centre of the Earth, there is a raging hot, fiery inferno. In fact, the deeper you go into the Earth, the hotter it gets. Underneath the crust is a layer called the mantle. Now, this is the thickest layer of Earth's layers, and it's 3,000 kilometers thick. It's made of molten rock, which slowly flows beneath the crust above, like hot, sticky toffee. As you get closer to the centre of the Earth, the heat and pressure build so much that when you reach Earth's core, which is made of heavy metals like nickel and iron, the temperature is 6,000 degrees C, and that's the same temperature as the surface of the sun. All that energy at the core wants to escape, like steam inside a boiling kettle. It pushes outwards, putting immense pressure on the middle section, the mantle. This puts pressure on the crust, which is actually broken into pieces like the cracked shell of an egg. We call those pieces on Earth's outer shell plates. And if you could break them apart and lift them off the mantle, they would look like this. The plates are floating on the soft, hot, sticky melted rock in the mantle, and they're being dragged on the surface by forces from deep within the planet. Think of the mantle like a pot of boiling soup, and the Earth's core is the fire and the mantle is the boiling soup. As the soup near the fire heats up, it rises, and as it gets close to the surface, it cools off and sinks. In physics, these are called convection currents. A similar process is driving the mantle, and it pulls the plates along with it. That movement of the plates by convection currents in the mantle is called plate tectonics. This process is like an engine, which is driving the constant transformation of our planet's surface. Check this out. Because the plates have been moving around on the surface for millions and millions of years, well, 200 million years ago, all of Earth's continents were connected, forming one huge supercontinent called Pangaea. And this is what it would have looked like. You can see Africa in the middle, North America wedged up next to it, and South America too, and there's Antarctica in the bottom. They would have all been connected. So as the plates have moved, oceans have expanded and land masses have smashed into each other, creating mountains. We call the places where the plates meet each other plate margins. And this is a great map to show you where the plate margins are. Firstly, Just look at the green areas, and those show the land masses and the continents. The continent of Africa is right in the middle. The blue areas are the oceans, just like a normal map. Okay, with the red lines, they show where the plates meet each other. And the arrows are showing the direction that the plates are moving as they get dragged by those convection currents in the mantle. If plates are crashing into each other, like on the west coast of South America, here we've got the Nazca plate crashing into the South American plate. If they crash into each other, we call them destructive plate margins. If they crash into each other, they're called destructive plate margins. If plates are moving away from each other, like in the middle of the Atlantic Ocean, we call them constructive plate margins. So if they're moving away from each other, as you can see with the arrows in the middle of the Atlantic Ocean, they're moving away from each other, we call them constructive plate margins. We're going to look at those two different plate margins in more detail in our next revision lesson.